Hello everyone. Today what we are going to be looking at is how to use the triangle congruency theorems. So yesterday we found out that we really have 4 theorems that allow us to conclude that a triangle is congruent if only parts of the triangle are congruent to each other. And those theorems are SSS, SAS, ASA, and AAS. And remember with these, what it's essentially saying is if you know that 3 sides are congruent according to the side, or SSS theorem, you'll be able to say that the whole triangles are congruent, which in turn will let you make conclusions like A is congruent to A prime, B is congruent to B prime, and C is congruent to C prime, even though there's nothing in the angles to indicate that before. Same thing with side, angle, side. I know that if 2 sides are congruent and the angle between them, that's why the angle is between the S's here in SAS, is congruent, then this remaining side will be congruent to this remaining side. This angle, B, will be congruent to this angle, B prime, and this angle, A, will be congruent to this angle, A prime. And that continues for each of the others. Remember that you have to watch the placement with these, because in this one we have angle side angle, which can be confused with angle angle side. And I mean, they sound really similar, but they really are talking about 2 distinct situations. Here the side is between the 2 given angles, so you can see there's an angle with the side and then the angle following. And here with AAS, we have an angle given, and a side that's not between the 2 angles given. So in this case, angle, angle, and then a side not between those 2 angles. Please watch out. We do have a few tricky ones. Don't forget that AAA is not enough information because you might have similar angles but different side lengths, so that you could have these pictures and you would not be able to conclude that the sides are congruent because, well, for one, they're just not, and 2, this just isn't sufficient evidence. And also not applicable is the SSA, which is really close looking to this one. The SSA does not work, so please watch out for that, because when you're doing these, you might end up with a triangle that kind of like flips in. And what I mean by that is this picture right here. When you are taking that final side, yeah, these 2 sides are congruent and this angle is congruent, but see how this side could be on the outer portion with a large angle for A, or be turned into the inner portion with a small angle for A. Well, that would result in 2 different possible triangles that still have congruent sides and a congruent angle. And this side would not be congruent to this side. This angle would not be congruent to this angle. And this angle would not be congruent to this angle. So that's why the SSA doesn't work. And it really does matter what order you have when you're talking about the sides and the angle. Is it SAS or is it SSA? Ultimately, what we want to do is solve problems. And the first step to solving problems with congruent triangles is figuring out if the triangles are themselves congruent. And with this, what we're going to be doing is we're going to just take a lot of care looking at how these angles and sides are positioned. Here I have 2 sides congruent to 2 other sides. I also have an angle between both of those congruent sides. So that means that what I have here is a side, an angle, and a side where the angle is between. Now what I can do is I can check and see, is that one of my theorems? And I added my triangle congruencies to my theorem note sheet in my formula note card. That way I can just kind of check it off. And SAS is one of my options. So that means that these 2 triangles are congruent, and I could say that triangle ABC is congruent to triangle, well, A corresponds with X, so X replaces it in the statement. B corresponds to Y, so I switch B out with Y, and last but not least, that means that C and Z correspond, which you can see because, hey, they're marked. So that's my congruency statement telling me that these 2 triangles are congruent. For my next one, I can do the same sort of thing. Again, I'm given an angle, a side, and an angle that's congruent to another angle, a side, and an angle. And notice that in both of these, you have to double check that side does come between the two angles. Well, that means that I have an angle with a side between and another angle. Since ASA is one of my theorems, it's this third one here, that means that these two triangles are congruent. And I could write the congruency statement. Now keep in mind with these, order does matter. Here we have a side, and an angle, a side, and an angle. So I'm looking at SSA, watch the order there. And the angle is not between the two sides, so I know I can't write SAS. I can look at my list if I don't remember, and I know that this is not one of the options. So because it's not one of the options, in fact, I have a counterexample, I can say that these triangles are not necessarily congruent. Now, could they be? Yes, it's possible that they are congruent, and I just need another piece of information. So for instance, if you told me that B was congruent to E, I would have angle side angle, which would tell me that these are congruent. Or if you told me that B, like AC was congruent to FD, well, that would make that third side congruent, so I'd have side, 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 and I'd be able to prove it. But at this point, I don't have enough information. However, if you're looking at the one next to it, I do have a side, congruent to another side, another side, another side. And since that is one of our theorems, I'm good to go. These triangles are congruent. Now what we're going to do is we're going to kind of skip to some of the harder ones. So let's go with the tricky ones. When we're looking at this one looks like all of the other ones that we've done. However, it's not. And that's because if you look at this side being marked congruent to this side, see how they have like these angles attached to that side? Here, K is told to be congruent to U, even though we want it to be congruent to S. Now because of this is actually forming two different triangles because these two angles that should correspond do not, which means that these triangles are not congruent. Even though the markings make it look like they are, you have to really watch the placement of those markings to make sure that you are actually matching up the correct sides and angles. We're also going to have ones that try to trick us in terms of extra information. So let's look at this one here. Now currently I know that this side is congruent to this side, and this one is congruent to this one. However, I can actually conclude that these two triangles are congruent, even though I only have two assets. And the question is, how do I do that? Well, don't forget that in a picture, you're allowed to assume that if you have two intersecting lines, they are going to form vertical angles, which means that this angle ACB will be congruent to angle ECD because they are formed by vertical angles, and that's the vertical angles theorem. Now that means that really what I have is a side, and an angle between that's congruent. So that makes this side angle side, which is one of our congruency statements, and so triangles here are congruent. And you should always look for vertical angles when you're trying to find congruency. And so you guys can even add a look for here on your card. Look for congruent, when you're looking for congruent angles, look at vertical angles. Now, you can also find other things in common, and sometimes it will be enough to get you to the end, and sometimes it won't be, but it will at least give us some more information. So if I'm looking at this triangle here, what I have is I have an overall marking for B. It's not actually saying that these little things are congruent to each other. But I do have two triangles that I want to see if they are congruent to each other. So I have this triangle here, and I have this other one here. I know that they have a side in common. I know they have an angle in common. What I need is a little bit more information. Again, this marking is only talking about the overall broad angle. One thing that I notice here is that these two triangles actually do share something, and what they share is this side. And because this side is in and of itself, of course, the same length as itself, like BB is going to be the same length whether it's attached to this side or to this side, that means that that side is congruent to itself, and that's the reflexive property, if you remember back to our proofs. Now, I have to check, though, even if I added this extra piece of information, do I have enough information to conclude that these triangles are congruent? And currently I have a side, and an angle that's not between, which makes this SSA. And that is not one of my congruency ones. So currently I actually don't have enough information. Now, will I be able to maybe find out more? Yes, potentially, but not yet. We don't have enough formulas or theorems for that. So for now, all you can say is that there's not enough info or information. And just because there's not enough information doesn't mean we haven't learned something new. So take your card and remind yourself to look for shared lines or even angles. Because sometimes it will be enough information. So let's look at two triangles here. Now there's a lot of triangles here. I'm going to look at the ones formed by the sides that are given to me. So I can see that this side is congruent to this red side, right? So I'm going to start by kind of looking at those. This blue side is congruent to this blue side. So you can see like two big triangles that are kind of popping up, both of which share this bottom line. Now, since they share this bottom line, that means, according to the reflexive property, that side is congruent to itself. So this triangle, this blue one, side, 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 match up with this red triangle, side, side, side. And that means that I have the SSS triangle congruency theorem. And I could say that these triangles are congruent. I might even be able to prove some smaller triangles are congruent, but we don't need to do that at this point. For now, what I want you guys to do is double check Classroom where you have an assignment posted. That one will practice these principles. Again, watch out for shared sides and vertical angles, and also double check your information to make sure it actually lines up. Have a great day.